Hi, this is Jeff Spence, your Math 120 instructor for the Community College of Denver, and this is the second half of my video lecture over 3.7, doing validity of arguments. So I ended the first half doing these examples, and I'll just continue on. Remember that an argument is valid if the premises are assumed to be true and lead to a necessarily true conclusion. Otherwise, if we have the premise assumed to be true and we can't necessarily conclude that the conclusion is true, then the argument is invalid. So we have some standard forms here that help us kind of guide what's valid and invalid. Basically, if I set up the example into symbolic notation and it fits one of the valid forms, it'll be valid, and if it doesn't, then it will be invalid. So let's go on. For each of these initial premise, you got to define what P and Q are. So P will be don't get paid. Q will be quit the job. All right, so our first premise is if I don't get paid, I will quit the job. So this is if P, then, if P, then Q. All right, our second premise is I got paid. So I defined P being don't get paid, so getting paid would be not P. And then the conclusion, it says I didn't quit the job, so I defined Q as quit the job, so this would be not Q. And this is invalid because this is the fallacy of the inverse. So that shows up right here, the fallacy of the inverse. If you have if P, then Q, and also not P, that does not lead to not Q. So that's an invalid argument. All right, next one. Either you move out or you don't get the job. So P will be move out. Q will be don't get the job. All right, so our first premise here, that's an or statement. So I'm going to say P, first premise is P or Q. And then the second premise is I got the job. Q is don't get the job, so this is going to be not Q. And then the conclusion here is I didn't move out, so that would be not P. And that is not valid. If we have a premise that says P or Q happened and we know Q didn't happen, the only conclusion we can necessarily make is that P did happen. So this is invalid. This actually doesn't fit into any of the invalid forms, but it doesn't fit into any of the valid forms, so we know that it's invalid. In other words, if we say for sure, if we can assume that P or Q happened, then either one of them or both of them has happened, and we know that Q has not happened, so the only conclusion that we can possibly make validly is that P did happen, and this concludes that P did not happen. So this is invalid. All right, next, if the Broncos are on TV, I won't be doing yard work. So I'll do P is Broncos on TV. And then Q will be won't do yard work. Okay, and then the first premise, this is an if-then statement, so it's going to be if P, then Q. All right, so then the second premise is I'm not doing yard work. That's the same thing as Q, won't do yard work, so that's Q. And then the conclusion is that the Broncos are on TV, so that's P. This is invalid. This is the fallacy of the converse. If the Broncos are on TV, then I won't be doing yard work. Well, not doing yard work is not necessarily enough information to know that the Broncos are on TV. You could be not doing yard work because it's raining outside or something like that. But that is the fallacy of the converse. That's this one right here. If P, then Q. If you're giving Q, you can't necessarily assume that P happened. Okay, last two. So we got if I don't get paid, I will quit the job. So let's see here. P will be don't get paid. Q will be quit the job. All right, so the first premise is if I don't get paid, I will quit the job. So this would be if P, then Q. Okay, a second premise is I didn't quit the job. So Q is quit the job, so didn't quit the job would be not Q. And then the conclusion, I got paid. Well, P was don't get paid, so this is not P. And this one is valid. This is the contrapositive reasoning. If P then Q, and then given that Q did not happen, then we know that P didn't happen. This is the contrapositive reasoning right here. It fits perfectly into that. So this one's valid. Okay, then the last one. If the Broncos are on TV, I won't be doing yard work. So I'm going to copy this. Broncos on TV is P. Won't do yard work is Q. Broncos on TV won't do yard work. Okay, so the first premise is an if then. So if P, then Q. Second premise is Broncos are not on TV. So P is Broncos are on TV, so this is not P. And then the conclusion says I'm doing yard work. This says I won't do yard work, so that's not Q. This is invalid. This is the fallacy of the inverse, which is right here. If P then Q, given not P, you can't necessarily conclude not Q. So that is an invalid argument. I think that's all the examples we have. We'll see you next time.